Hello friends, welcome to my channel. Let's have a look at problem 105. Construct binary tree from preorder and inorder traversal. This problem actually is a follow-up for today's daily challenge problem, that is problem 106. So here the given list are preorder and inorder traversals of a same binary tree. So we are required to construct and return the binary tree. So here are two examples, and similar as in problem 106. The example 2 is a special. It contains only one node. And in example 1, because here currently we are using preorder traversal, so the first element in the preorder will be the root value. And then because the preorder and the inorder consist of unique values, so we can find the index corresponding to the root value in the inorder. That is 1 here, right? Index 1. Then to the left of the inorder, this will be the inorder traversal for the left subtree. And to the right is the inorder traversal for the right subtree. And then we can similarly find here. So this is the left preorder traversal of the left subtree, and this is the preorder traversal of the right subtree. So in between, we notice that the preorder and the inorder traversals for the same trees are always of the same length, right? So this is the invariant. So with that said, we are ready to look at the treatment and coding. So here we actually would review or explain a solution based on recursion. So the reason we think of recursion is that binary tree is a recursive abstract data type because it can be defined recursively. So in this video, we want to notice two things. First, we need to pay attention to the second item here. That is, the values of nodes in the binary tree are unique. And secondly, so we need to pay attention to the item 1 here. That is, when we write the recursive solutions, so we need to pay attention to the index, especially +1 or not. So with that said, we are ready to do the coding. So because we are using recursion, first I'm going to write a condition to check base case. So we know that always the preorder and the inorder lists are of the same length because they are corresponding to the same trees. So first let's do this. If not, preorder. So in other words, the corresponding tree is a null tree, so we can just return null. Then after this if check, so the preorder is not empty. In other words, we can use pop operations. So here let's first get the root value of the full tree. So we can get it from preorder. So here I'm going to use a pop. So I'm pop from index 0. So one way to do it, maybe also you can convert this preorder list to a deck, or also maybe this one. And that's actually maybe accelerate a little bit. But here, due to the assumption of the problem set, this will be okay. So once we get this v, we know the root value. So for example, if we use example 1, you know this v is 3 at the very beginning, right? And then we want to find the index of this 3 in the corresponding inorder traversal list. So let me do this, idx. So let's call this index method, so the value. And then we are ready to construct the tree. First, I'm going to construct the root. So this is the tree node. The value will be given by the v, right? And then we would like to set its left subtree and right subtree by do self calls. So this by doing self calls left equals self build tree. So here I would like to get first I'm going to write in order, right? So we know the index is here, so we're going to write this as index. In other words, the left part. So we know the preorder and inorder traversal of the left subtree should have the same length. So we're going to do this preorder. So because we have already popped the first element, that is the root value, so we can directly write here idx. So this way, as a sanity check, you can notice that this preorder and inorder piece have the same length. So now let's set the right. So it will be self-build tree. Then here we are up to here, right? That's the preorder. And then we know that, so preorder, after the preorder, then everything else is corresponding to the right subtree. So here in the in-order traversal, because we cannot include this 3, right? So we need this 3 corresponding to index. So for the in-order traversal of the right subtree, we're going to start from index plus 1. So that is idx plus 1 here. So we can check actually these two have the same length. The reason is that the in-order is 1 longer in length, because we use a 1 pop operation in preorder, but we didn't use in inorder. So we write idx plus 1. So this will make the 2 have the same length. So with that said, we are ready to return the result, that is the root. So this piece of code forms a solution format to this problem. So before we do anything, let's first do a check. Yeah, it passes the first example. Now let's look at generic case. Yeah, it passes all the generic cases. So I would say that this is just a one version of solution to this problem. So you can actually modify the solution to make it shorter, or you can say do some type conversions, or just do not use pop operation. You still can make this problem done. So with that said, I guess that's about it for this video. If you find it's useful, you're welcome to share with your friends. Thank you.